garage parking assistant. So before I begin this session, so just a little bit a background about this one. So we do these type of projects in the first year uh, in the university, and we conduct these type of experiments and these type of projects in our labs, which are highly interactive. And we are there to assist the students, and they make these type of projects in our labs. But due to COVID-19, we have to resort to this online mode of communication. So this presentation would be partly online, and then there would be a small demonstration towards the end of his smart garage parking assistant. So let's just begin about this. So smart garage parking assistant. So in this session, you will learn about what the embedded systems are and what are its three main components. And then towards the end, we will build a smart garage parking assistant, which will be the main component of this session. And we will do it in Tinkercad. And then we will have a demonstration in the real Arduino Uno microcontroller. So first of all, let's see what embedded systems are. So you see computers everywhere, be it your desktop computers, your laptops, your tablets. So these are all examples of computers. But surprisingly, you see some other forms of computers or mini computers uh, everywhere in your house, in your schools, in your buses, even in your pockets. And we call these computers as embedded systems. Some common examples are your mobile phone, your microwave oven, your MP3 players, the routers in your houses, maybe your fridge. So all of these examples, all of these devices are examples of embedded systems. So what are the three main components of an embedded system? An embedded system basically has three main components. The first one is its brain. The second one is the input devices, and the last one is the output devices. So the brain is actually the mini computer or the microcontroller, which we refer to as a mini computer, and it acts like the brain of a human. So it makes decision based on the input that it gets from the input devices, and it directs the output devices to do some certain tasks. So the next component is the input device. So these are responsible to get input from the environment or from the users. And usually they are sensors like light sensor, which detect the light intensity, whether it is dark or it is there is light in the environment. Likewise, temperature sensor to detect whether it is hot or it's cold. And distance sensor, which measures the distance of an obstacle or an object from a certain device. And then there are some output devices such as lights, light emitting diodes, speakers, motors, and they get commands from the brain, which is in our case the mini computer or the microcontroller, which is responsible to make decision based on the input it gets from the input devices. So if you look at any embedded system, be it your, say, a fridge, your microwave, it would have these three main components: the brain, some input devices, and as well as the output devices. So in this session, we are going to make a garage parking assistant. And why are we making this garage parking assistant? So the reason is in your garage, most of the garages, the space is quite limited. And this makes the parking in a garage quite challenging, especially for the new drivers. And there is always a risk for damage to the car or to the garage wall, because the driver is not able to determine whether there is enough space at the front of the car or at the back of the car. And sometimes he or she might hit the garage wall, and sometimes he or she might park the car way far from the garage wall, and it might hit the garage door. So it's a little bit challenging, especially for the new drivers. So what people came up with the solutions were or are, so one solution is to fix some parking guide bars in the garage. Uh, so like here, so as soon as the car tire hit the parking guide bar, then it means that the driver has to stop here, and it means that the car is also saved at it's also parked at a safe parking distance. The other option that they have come up with is to hang is tennis ball, and as soon as the car hits this tennis ball, it means that they are at the safe distance and the perfect spot. So they just park their car there. And the third one is just a sophisticated way of using this tennis ball. It's basically to use this laser beam instead of the tennis ball, and as soon as the driver sees the laser beam on their dashboard, it means that they are at the best spot to park, so they park their car at that location. So these are some of the ways to assist a driver parked in the garage, which is quite challenging. So obviously there are solutions. The first solution, which is fixing some parking guide, it's a tripping hazard. So you walk and then you might trip due to these parking guide bars, especially for small children. So it's quite dangerous. Likewise, this laser beam, this is also very dangerous for the health, for your eyes. So there are some health related hazards related to these solution. And then this tennis ball is quite annoying. Like you see, you go to your garage and you see the ball hanging from the ceiling of the garage. It's quite annoying, although it's safer than both these two other solutions, but still it's a little bit annoying. So the purpose of this session is to come up with a parking assistant, which is better than these solutions. And we are going to make it based on an embedded system. So as we discussed, so there are three main components. There would be a brain of the embedded system. So the brain, which I discussed, is the main thing which is responsible to make decisions. And usually we use a microcontroller, and we are going to use an Arduino microcontroller, which is readily available and is quite cheap as compared to its competitors. So we are going to use a microcontroller named Arduino Uno microcontroller, which is given here. This is the brain of our embedded system. And then we are going to assist the driver by measuring the distance of the car from the garage wall. And how do we measure the distance? We use a distance sensor, which is an ultrasonic sensor. So it measures the distance from the car, how far it is from the garage wall. So we are going to use this as the input device. This is your brain, this is your input device. And then how we are going to assist the driver? We are going to assist the driver by using sort of a traffic light signal model. So if it is green light, it means that the driver can proceed. If it is a yellow light, then it means that they need to stop in a while. And then when it becomes red, then the driver has to stop there. It means that he or she has parked the car in the right spot, and and they should not go further because they are already in the perfect spot. How to operate is basically, for example, if your car is far away from the garage wall, so this is the garage wall, and this is your car. So if it is far away from the garage wall, so what do? We turn off all the lights to save some energy, to save some power. But as soon as it approaches the garage wall and it is at a safe distance, we direct the driver that they are good to go, they should proceed. So we turn on the green light. So it means that, or it indicates to the driver that they are that it's safe to go forward. So we indicate it when the car is at a safe distance and it's a little bit far from the garage wall. But as soon as the car approaches the wall and it approaches the right parking spot, what we do, we turn on the yellow light, which would indicate to the driver that they are approaching the right spot, so they would be stopping in a while. So they should prepare to stop. And as soon as the car is at the right spot, we turn on the red lights. It would mean that they have to stop here because you already have come to the right spot. So there's no point of further. So if you go further, you might hit the garage. So this is the way we are going to assist the driver. So how we are going to implement this? So first of all, we are going to implement it in Tinkercad, which is an online platform to design and simulate some circuits. And then towards the end, we will see a physical implementation of this garage parking assistant in an Arduino Uno microcontroller. So let's do the implementation on Tinkercad. So this is the website. If you want to follow me, feel free to do so. So you just type in tinkercad.com, Tinkercad, and then .com, and then you join if you haven't created an account before. But if you have created an account like me, you can just sign in, and then you just provide your email address and your password. So I'm just gonna log in, and as soon as you log in or you create an account, you see this type of screen here. So on your left, you see there are some tabs such as for 3D designs, for circuits, for code blocks, and for lessons. So we are going to click on circuits because we are going to make a circuit. And then you just create a new circuit. So once you create a new circuit, you'll see this screen. So first of all, what we are going to do, we are going to name this project. So we are going to say it's a garage parking assistant. So we can do so here by just changing the name here. And then we are going to build the circuit or the embedded system. And remember, we had three main components. The first one is the microcontroller or the brain, which is the Arduino microcontroller that we are going to use. So as soon as you type it in the search window, you will see an Arduino Uno microcontroller appearing on your right side of the screen. This is the brain that we are going to use, or the microcontroller that we are going to use. For our convenience, I'm just going to rotate it and to make it vertical. So I have made it vertical here. And then I search the input device, which is an ultrasonic sensor. So I just write ultrasonic sensor. It will show the ultrasonic sensor. So I will just click on it and drag it. So I get this ultrasonic sensor, which is the input device that we are going to use. And then we are going to use the output devices, which are the LEDs or the lights, which would be green in color, the red light emitting diode, and the yellow light emitting diode. But how do we fix them? For that, we need something to place these LEDs on, and we have something called a breadboard. So as soon as I search it, you will see a breadboard there appearing on the right side. So you just click on it and drag it, and then I'm just gonna rotate it for the convenience. So we have the input device, we have the brain, and then we have the output devices, which is going to be an LED, which stands for the light emitting diode. So this is the light emitting diode, and it's red in color. Again, I'm going to rotate it for the convenience. So, so this is the red LED, and then if I copy it by using the shortcut Control C, and then just paste by using Control V. I get another LED. I can change its color to yellow, and then I can again copy it by using Control C and Control V. I get another LED, and I can change its color to green. So we have input devices, we have output devices as well as the brain. So first, let's try to interface the input device to the brain. So if I look closely at this input device, which is the ultrasonic sensor, it has 4 pins: VCC, trigger or trig, echo, and then ground. So two amongst them are quite obvious, which is the ground and VCC. So, and this is your brain. We are going to interface this input device with the brain. And if you look closely at this brain or the microcontroller, you see that it has some ports here which are related to the power, which is ground, 5 volts, V input, and 3.3 volts. And then the remaining are for input and output. So these are known as the input output ports, whereas these are known as the power ports. So how do we interface an ultrasonic sensor? We connect, so this is the ground. So we connect the ground with the ground of this microcontroller. And if you just click on it, it will show this wire. And then I can just use the mouse to connect the wires. So I have connected the ground of the ultrasonic sensor with the ground of the brain or the microcontroller. And it's a good practice to use black color wires to connect the ground with the grounds, to represent the ground signal. And VCC stands for 5 volt. So how do we do that? We just click on it and then connect it with the 5 volt supply here. So this is the 5 volt supply. And it's also a good practice to use red color to represent the supply voltage, which is in this case. So now we are left with only 2 pins, which are known as the trigger pin and the echo pin of the ultrasonic sensor. So the trigger and echo pins are the input and output pins of the ultrasonic sensor. So the trigger pin gets input from the microcontroller, which directs it to measure the distance. And when it measures the distance, it outputs its distance on the echo pin. So basically, we are going to connect the trigger pin, say, to any input-output port of the microcontroller, which in this case is going to be, say, let's say we are going to use A0, and say we are going to connect the echo pin, which is the output of this ultrasonic sensor, which measures the distance of the car from the garage wall. So we are going to connect it to the port A1 so that we can get the input from the ultrasonic sensor to the microcontroller. So we have successfully interfaced the input device with the brain or the microcontroller. Now let's interface the output devices with the microcontroller. I'm just going to drag the whole circuit towards the left. So here you see something which we call as the breadboard. So it's nothing but just the combination of different wires which are connected together. So if you look closely at this piece, it has something called plus and negative rails here. So this is called the power rail, and this is known as the ground rail. So if I just hover on any of these points, so you see all of this line gets highlighted, which means that all of these points are connected together. Likewise, if I hover on any point on this negative rail, it would highlight all the points, which means that all of them are connected together. And if I hover on any point here, say here we have different rows of dots here, it means that all of these points or all of these connections are connected together. Say if I look at row number 5, it would say this, and this points are connected together, which are given by A, B, C, D, E, and this is the 5th row. Likewise, if I say hover any row here on the right side, say row number 2, then this, and this all are connected together. And these are just single wires that are connected together. So it is for our convenience and how it enables us to put different devices here. So I'm just going to drag one of the LEDs, say the red LED, and put it here. So let's say I put it here. So if you look at any LED, say let's look at this yellow LED, it has two terminals. One of them is known as the cathode, the other one is the anode. So the anode should be at higher potential than the cathode. So what we do is that we connect the cathode to the ground. So let's first of all fix them on the breadboard like this. And then we connect these LEDs to the ground. But since the LEDs do not work with 5 volts, they only require say 2 to 3 volts maximum. So what we do, we protect them by using a resistor. So I just search resistor and I drag it here. And then again, for convenience, we just make it horizontal and say I use 100 ohms resistance. So I just drag it here, and then I can copy it and paste it by using Control C and Control V, like this. So if I look closely at this connection, what's happening is that the cathode of this LED is connected to one terminal of the resistance, and the other terminal of the resistance gets connected with the whole rail. And then if I just connect this pin number 6 to one of the dots here in the negative, it means that I have connected it to the negative rail. And which is what we are going to do. We are just going to connect the ground with the negative rail. So I can use say a black color to represent the ground. So basically, I have connected the ground with this negative rail, and then this negative rail is connected to the other terminal, to the one terminal of resistance. And I can also use black color here. So this resistance is connected to the ground, and the other terminal of the resistance is connected to the cathode of the red LED. We can do similar things with other LEDs to protect them, and we can use say black colors to represent that it is connected to the ground. So basically each individual LED is connected with a resistance to the ground, the cathode of each LED. And for the anode, we connect their anodes with one of the pins. Say, let's see, I can connect it with say pin number 10, the red LED. And then say let's connect it with pin number 9 for the yellow LED. And then for the green LED, let's connect it with pin number 8. So we have connected a red LED with pin number 10 of the LED of the microcontroller. We have connected the yellow LED with pin number 9 of the brain, and we have connected the green LED with pin number 8 of the Arduino microcontroller. And I have used red, yellow, and green color for as the matching color for the LEDs. So our circuit is complete. So this is our whole circuit. So we have the brain, we have the input device, we have the output devices, and we have established the circuit as well. Now, how do we direct the microcontroller to take input from the input device and um, appropriately select the color of the LEDs to assist the driver. So for that, we need to write a code for the microcontroller. And how do we write a code for the microcontroller? So in this Tinkercad, we have this tab, which is called code. So if you just click on it, I see this type of figure popping out, which has an inbuilt code in it. So I just drag it and send it to the trash can. So the idea is that we measure the distance from the ultrasonic sensor, and based on the distance, if it is far away from the garage wall, we do not turn on any LED. And if it is at a safe distance, but it's not very far from the garage wall, we turn on the green LED, which means that the driver should proceed. And then as soon as the driver approaches the garage wall and is near the perfect spot, we turn on the yellow LED, which would mean that they need to stop in a while. And then as soon as the driver reaches the perfect spot, we are going to turn on the red LED. So let's first of all get the distance from the ultrasonic sensor. So remember, we have input devices. So for that, first of all, we need to create a variable. So I just click on it and say I'm going to measure the distance. And then how do we measure the distance? We set the distance. So we just drag this set distance to, and here it is 0, which means it's going to initialize the distance to 0. But instead of initializing it to 0, we can just take the input from the ultrasonic sensor. So if I just click on the input, it says read ultrasonic sensor. So I just drag it here. So it says set distance to read the distance of ultrasonic sensor, and you have to specify the trigger pin as well as the echo pin. So I look closely. The trigger pin is connected to pin A0, and the echo pin is connected to pin A1. So I specify that the trigger pin is connected to pin A0 and the echo pin is connected to pin A1. And we are going to measure the distance in centimeters. So we first of all, we get the distance, which is the input to the brain or to the microcontroller. Now we perform some logic on it. So the logic would be if the distance is far or it's very high, which means that the car is very far away from the garage wall, we do not turn on any LED. So for implementing that, we have something called a control or the logic part, and it has if block here. It's meant for implementing logic. So the idea is we would write here the code which would say if the distance is very large, then we turn off all the LEDs. So how do we write this? So if, and then I say if the distance, so I would go to the math portion of this. So I would say if the distance is say greater than 100 centimeters, then, so if I drag this one here like this, so it says if the distance is greater than 100 centimeters, what I need to do, I need to turn off all the LEDs. And this red LED is connected to pin number 10, yellow LED is connected to pin number 9, and green LED is connected to pin number 8. So I'm going to use the output, and I'm going to set pin number 10 to low. So it means that we are going to turn off the red LED. And then if I right click on it, it says duplicate. I just duplicate it. So I'm also going to turn off the yellow LED, which is connected to pin number 9. And then I just duplicate it and put it here. And then I say that you also need to turn off the green LED, which is connected to pin number 8. this is when the car is far away from the garage wall. But now, if the car is a little bit close to the garage wall, but it's at a safe distance, what we need to do, we need to turn on the green LED. So we do this the same way. So if the distance is now say between 100 centimeters and 50 centimeters, we are going to turn on the green LED. So we again use this math, and here I say if the distance is between 100 centimeters and 50 centimeters, I'm going to turn on the green LED. So how do we do that? So I just put it here and put it here. So if the distance is say less than equal to 100, which means that it is not very far, but it's at the safe distance. So the distance is greater than 50 centimeters. It means that the driver is at the safe distance or the car is at the safe distance. So how do we indicate that? We are going to turn on the green LED. So we just click on duplicate and then drag it. So it's gonna duplicate this whole block. So the green LED was connected to pin number 8. So I'm going to turn it on. So now, if the distance is far, it's not very far, it's at a safe distance. So which means the driver should be moving forward. So we turn on the green LED. Now, if the car approaches the right spot, say distance is between 50 centimeters and 30 centimeters, or say 20 centimeters, we are going to indicate that you are approaching the right spot, but you need to stop in a while. So we are going to indicate the driver by turning on the yellow LED. That would indicate to the driver that you are going to approach the right spot, so you better prepare to stop. And then towards the end, if the distance is very small, say it is less than equal to 20 centimeters, so I again drop the distance here and specify here, say less than equal to 20 centimeters. Then I'm going to turn on the red LED. So basically, when the distance is very large, which means the car is far away from the garage wall, we turn off all the LEDs. And then if it is at the safe distance, but it's not very far, we would indicate the driver to move forward by turning on the green LED, which is mathematically represented by distances less than 100 centimeters and 50 centimeters and is more than 50 centimeters. But when the distance falls below 50 centimeters, but it is more than 20 centimeters, it means that the car is approaching the right spot to park. So we would indicate the driver that they should proceed with caution, or they should be prepared to stop in a while. So we indicate the driver by turning on the yellow LED, which is connected to pin number 9. And then as soon as the driver reaches the right spot, which is say at 20 centimeters from the garage wall, we would indicate it by turning on the red LED, which would indicate the driver that you should stop because this is the perfect spot to park. So this is the way we are going to program this microcontroller. So I'm just gonna zoom out and see if we can simulate it to verify whether we have established the circuit correctly and we have written the code correctly. So how do we do that in Tinkercad? There is an option to do start simulation. So As soon as I click on start simulation, it would start simulating. It shows the time. And if I click on this ultrasonic sensor, it shows the distance. So if the car is far away from the garage wall, which is around 113 centimeters shown here, no LED is turned on. You can see from here. But as soon as the driver approaches the garage wall, you see the green LED has turned on, which would mean that the driver should proceed now because it's a little bit far from the right spot. Then as soon as it approaches the right spot, the yellow LED would turn on, which would mean that the driver needs to stop in a while. And as soon as the driver approaches the moves forward, the red LED turns on, which would indicate to the driver that you need to stop here. And here we stop. So this code is, or this logic is working perfectly fine. So we have implemented the circuit in Tinkercad with input device, the ultrasonic sensor, with the brain, Arduino Uno, and with the output devices, the LEDs. Now it's time to implement in the real hardware. So how do we do that? So for that, we need to program the microcontroller in a language which we refer to as the C language. We are going to teach you the C language in the first year. So at this time, I'm gonna just use the C code that is readily available from Tinkercad. But once you are in the university, we are going to teach you how to write the programs in the C language and how to program a microcontroller in the labs, where we interact with you and teach you how to connect a microcontroller with your computers and how to connect this, for example, ultrasonic sensor with the microcontroller. And then we also do a simulation as well as the real implementation there. But in the Tinkercad, there is an option to get the code as well. So if you just click on the code and go to the blocks plus text, it shows the C language corresponding to all of this logic. So I'm just gonna copy it and place it in the Arduino software, which is used to run it. So I just replace the whole code with this code. And then I compile it, and I shouldn't be getting any errors. It means that this code is compilable and it can be burnt in the Arduino microcontroller. So I did exactly the same thing and implemented this in a real hardware, which is shown here. So this is what I implemented. So you can see from here, this is the breadboard. This is the microcontroller or the brain. And this is the ultrasonic sensor. So I captured this with my mobile phone. So I would move my mobile phone closer to this circuit, and you will see these LEDs, this green LED, this yellow LED, and this red LED turning on as I move closer to this modules. So let me just show you. So this is, I'm moving forward. You see the green LED has turned on. And then as I move closer, the yellow LED would turn on. And as soon as I move very close, the red LED has turned on. It means that I have to stop here because the car has reached the perfect spot. So that brings to the end of my presentation. So let me just summarize what I discussed. So I discussed that the embedded systems are present everywhere, and it has three main components. The first one is the brain, which is the main component, and then there are input and output devices which are connected to this brain. So input devices give signal to the brain, whereas the output devices act on signal from the brain. Then we did some Tinkercad simulation to implement a small garage parking assistant. And then towards the end, we saw is a demonstration of this embedded system that we implemented in Tinkercad in an Arduino Uno microcontroller. So if you have any questions, feel free to ask. Either you can type it in the chat window or you can also take the mic.